Okay, so let's see what's going to be on the quiz. When's the quiz? Tomorrow? I'm not going to give you exact problems. Okay, you're in an honors class. I really shouldn't even have to review for an honors class for a quiz. Maybe for a test I would, but anyway, but I've gotten weak in my old age and I've started reviewing. I used to never review for a quiz. I would just tell you what lessons they covered and I'd tell you when we were taking it and that was it. But I've grown soft in my old age, so you're the beneficiaries of it. Okay, so I'll basically just tell you the style of problem that's going to be on there, okay? And I don't want that. What do I want? This. Okay. So, what do you think this is? Rhombus? Yeah, it's a parallelogram. Now, you don't know it's a parallelogram until I do this. If I did, actually, they tell you it's a parallelogram, okay? They say, they're going to ask you for some things, but they do tell you it's a parallelogram in the instructions, okay? Girls, I'm speaking now. Thank you. So in the instructions, it tells you that it is a parallelogram, all right? And they give you some lengths, right? They'll tell you the length of this side, and they'll tell you the length of this side. But they're going to give it in terms of x's and y's and that kind of thing, all right? So let's just make one up. What do you think that this is? 5x minus 2, 3x, I don't know, plus 4. I'm making these up. All right, so what would the length of these two sides be? What would you do if this was a parallelogram? You set them equal, right? Because the opposite sides of a parallelogram are equal to each other, right? So you set them equal, solve for x, plug it back in, you can find how long each side is. And this is going to have y's, whatever it is for the y's, okay? You with? Yeah, because this is equal to this, right? So you set those equal to each other. Now, the y's aren't going to be the same length as this. I mean, they could. The same kind of thing, yeah. All right, so this and this are equal. So you just set these two equal, solve for x, set these two equal, solve for y, plug them back in, find the length, you're good to go. All right, so there's two things you're going to find with this. You're going to solve for x and you're going to solve for y, then you're going to plug it back in. Actually, you don't even have to plug it back in. On that problem, it just says solve for x and y. That's all it says. Okay? Number 2's fairly similar. Let me copy this parallelogram. So 2 is kind of similar, except they throw some other stuff in here. And here's the other stuff. What is that thing right there? It's a diagonal. It's a diagonal. And what you have to remember is, what do diagonals do to a parallelogram? They bisect each other. That's right. So what you need to know is this and this are equal, and this one and this one are equal. And they're going to give you values for this little line segment, this little line segment, just like they did on number 1, right? Xavier? Thank you. All right. So they're going to give you this in terms of x. They're going to give you this in terms of y, or whatever letter they use. I used a and b. Doesn't make any difference, does it? All right. And you just set these two equal to each other. You set these two equal to each other, solve for a, solve for b. You're good to go. Good? Then you got another problem. Oh, that would be number 2. Actually, number 2 and 3 are very similar to each other. But the algebra on number 2 is a lot easier than the algebra on number 3. Why do you think I say that? What's the difference between number 3 and number 2? What could be different about the algebra? What did we learn in this section? Well, give me a word. Give me an algebra word. Substitute. That's right. Substitution. Remember that? Okay, so find the problems. Again, I'm not going to give it to you right here. But on number 3, you set it up the same way, right? This is equal to this. This is equal to this. But then when you do the algebra, you're going to have to do a little bit of substitution. All right, so the geometry is pretty much identical. I'm looking at it. Yep, it's identical, except you're going to have to do a little substitution for your algebra. Remember doing that? Yeah, we've done that before. Go back, watch a video, look at your notes. That's what I would do. Best thing to do, if you take good notes, you can flip through your notes a lot quicker than you can flip through a YouTube thing, right? So you flip through your notes, you find the one where it talks about substitution, you see what lesson that's on, then you can go to that lesson, right? And then watch that little bit of that lesson to see how to do it if you're not really sure by your notes. Everybody good? All right. Again, I'm giving you a review, but I'm leaving a little bit up to you. All right, so I'm not doing like every single problem for you, which is the way it should be, shouldn't it? It should be. You probably don't like it that way, but it's okay. All right, here's another one. This is number 4. You also have diagonals, but now you are looking at some other things. Remember, this is a parallelogram, so you know this and this are parallel to each other. And I'm going to give you this angle and this angle. Again, in terms of x or y. You know what that means? When I say in terms of, so it's going to be like 2x plus 3, or it's going to be like 3x, or it's going to be 2y, or it's whatever, okay? So if I give you this and this, what's true about these two angles? Very good. I like that. Perfect answer. They're equal to each other because they are alternate interior angles, okay? Parallel lines, transversal, they're alternate interior angles, so you set this equal to this, right? You solve for whatever the variable is, boom, you're done. Got it? And it works the other way too. Like, let's use this as our transversal. So this one right here would equal what? This one right here. Okay? Same thing with this one here and this one here. I don't want to write too many of those arcs. Kind of gets a little messy. Everybody good with that? Yep. And you just have to solve for x or y. Okay? You don't have to like plug it back in and find what the angle is. All you got to do is just find what x is, find what y is, and you're done. That was number what? 4. All right. Now you got another one. Except it is a parallelogram, but it's a special kind of parallelogram. What do you think it is? It's a rectangle. Good. And what do we know about rectangles? Right angles. Okay. Well, opposite sides are equal because it's a parallelogram, right? Opposite sides are parallel because it's a parallelogram, but right angles. Yeah, all 4 right angles right there. And they tell you in the instructions that this is a rectangle. You don't actually see the right angle symbol, but they tell you that this is a rectangle. Okay? So you have to make the assumption. It's really not an assumption, but you have to know if they tell you it's a rectangle, that means all 4 angles are right angles. You with me on that? They also give you diagonals. Now, we know that the diagonals bisect each other on a parallelogram, but on a rectangle, what do we know about the diagonals? Something a little bit more specific. What do we know about the diagonals of a rectangle? They're equal to each other. So I could say that what? AC equals what? BD. All right, so that's very, very important. And they also bisect each other, correct? So what if I told you that, I'm just making this up, what if I told you that AC was 10? And we'll call this M. What would AM equal? 5. Easy. Everybody with me on that? What would MB equal? That would also be 5, wouldn't it? Because the diagonals are both the same. They're both being bisected, right? And so every one of these would be 5. Every one of these segments right here that are part of those diagonals. We good? All right, yeah, easy. So that's 5 and 6. Is that right? Did I say the other one was 4? Yep. Okay, so this is numbers 5 and 6. I asked you 2 questions about that. All right, then I give you 7 and 8. I give you another rectangle. And I ask about some of the angles in it. All right, so let's get rid of these things. Let's get rid of that. Get rid of that. Okay, so let's call this angle, I don't know, angle 1. All right. Call this one angle 2. Call this one down here angle 3. And they tell you what this is. Let's just make up a number. What do you think that angle is right there? Just make something up. Nothing hard, nothing crazy. 7? Looks a lot bigger than 7. Remember, this is 90. 25? 45? 45 would go a little bit more this way, wouldn't it? Well, when I say any number, I mean a number that it looks like. No, there's no way that's 85 degrees. Give me an angle that this looks like.
30, 40, 50.
30, 40, 50 maybe, something like that. Let's say, I wouldn't even say 45. I wouldn't say 50. So I take away 50. Because look, where would 45 be? 45 would be like that, wouldn't it? Split that 90 in half. Okay, that looks less than 45. Would you agree? Anyway, it doesn't matter. I'll give you a number on the test or the quiz, okay? Yes. Right pass. All right, so, sorry it caused so much trouble. So let's just say it's 30. It's not on the quiz, but let's just say it is. All right, and I wanted to find those other ones. How in the world would I find those other ones? Well, if this is 30, what's this one right here? That's also 30, right? There's reasons for that, but they are equal to each other, okay? Because these two would be equal to each other, correct? Right? And then angles opposite equal sides are equal. So if that's 30, that's 30. How do I find this angle 3 right off the bat? How'd you do that? Yeah, just go 90 minus 30. All right, so this would be what, 60? All right, and what about this angle up here? Yeah, I only ask you for... Yeah, that's good. That's good enough. Look at these two triangles. Look. What's true about this triangle right here and this triangle right here? They're congruent to each other, aren't they? Side, side, side. Everybody see that? So, if these two are 30, what are these two up here? They're 30 as well, correct? What about this one right here? What is it? 120, good, because look, 30 and 30 are 60, and this is left over from 180. 180 minus 60 is 120. So that's 120, this is 120, and so on. What's this angle right here? That's 60, right, because it forms a straight line, so that's 60. We good? What's true about this side BC and this half a diagonal? I don't ask this on the quiz, but I just saw it. They're equal. Why? Because if this is 30, what's this? That's 60. If that's 30, what's this? What kind of triangle do I have here? And it's more than isosceles. It's true. It is isosceles. It's equilateral and it's equiangular, right? So it's equilateral, which means that this side and what? That side are equal to each other. That's just because I made that 30, all right? All right, enough of that. That was fun. That's not us, is it? All right, somebody mentioned rhombus earlier. That does not look like a rhombus, but that's starting to look like a rhombus. About like, does that look close? Close enough. What do we know about a rhombus? This is 9 and 10. What do we know about a rhombus? What's true about all four sides of a rhombus? They're equal to each other, okay? What do you know about the opposite angles? They're equal to each other. What do you know about the consecutive angles? They're not equal. The consecutive angles are what? Supplementary, right. All right. All that's true about a parallelogram as well, right? Except for the equal sides, all right? Equal sides is only true about a rhombus. But what if I did this? I know something. Now, we've already talked about diagonals. What do we know generally about a diagonals of a parallelogram? They bisect each other, right? We talked about that earlier in the review. But if it's a rhombus, it does something a little bit more special. It makes it perpendicular. That's right. So this is perpendicular, which means it's a what? It's a right angle. Okay? And let's see what I want to say. Yeah, they give you one of the angles in here, okay? They're going to give you one of the angles. I'll tell you which one they give you. They give you that one right there. And you want to find some other angles. Call this 1. Call this 2. Call this 3. They give you this one. How many degrees do you think that is? Kind of looks like 45, doesn't it? But if that's 45, I'd say that's a little smaller than 45.
40, 35.
Because this is an obtuse angle, isn't it? It kind of looks like it does what? And what does it do? It bisects it, right? So what do you think that is, that angle about? No, the whole big angle. This whole big angle. It's not 90. It's definitely not 90. 90 would go straight up. 100? Okay, let's say 100. Let's say this is 100. So what's this angle right here then? That'd be 50. Okay, what would this angle right here be? They'll give you one angle. Well, they'll just give you one angle. They could give you the whole angle. Okay, me. I'm the one that made it. All right, so I could give you the whole angle. Excuse me. Or I could give you each of these. Either way, just as easy. All right, so if that's 50, because you remember what happens with the diagonals of a rhombus? They are perpendicular, but what do they do to the opposite angles? They bisect them, that's right. So that's 50. That's got to be 50. Yeah, I'll give it to you. Yeah, you're not going to have to guess what it is. Yeah, I'll definitely give it to you. I'm just trying to pick numbers that I'm not giving you on the quiz, just so you don't memorize the answers, okay? That's all I'm trying to do. All right? So if that's 50, let's find the other angles. What do you think? Well, what's angle 3? That's 52 because remember, or 50 also, I should say. It's not 52. It's 50 also. Because remember, these opposite angles are equal to each other. So this bisects this too. So this whole thing's got to be 100. So this has to be what? 50. All right? What's angle 2 without doing any math at all? 90 degrees. Angle 2? Angle 2 is 90 degrees. Okay, remember, they're perpendicular. So that's 90. If that's 90, that has to be 90. Agreed? Now, very easily, how do you find angle 1? What math? Remember, this is 50. Say it. 50 plus something? Yeah, let's not go 180. It's easier than that. We talked about this yesterday. Yeah, just go 90 minus 40, or 50. That's the answer. 90 minus 50, right? Because you're already going to go 180 minus 90. Why do that every single time? When you have a right triangle, these two angles right here, these two acute angles, they're always complementary, which means they do what? Add up to 90 degrees. So if you know one of them, how do you find the other one? Just take it away from 90. Now, could you go 180 minus 90 minus 50? Sure. But what's 180 minus 90 every single time? It's always, 180 minus 90. 180 minus 90 is 90 every time. So these two acute angles always add up to 90 on a right triangle. You got it? So it's a lot easier just saying 90 minus 50, which obviously is 40. So angle 1 would be 40. Everybody good? Okay. There's your quiz. Super easy. I expect very, very high grades on this. The one thing you really need to study, I think, is the one where you have to do a little substitution. Okay, so look in your notes, find out where we did substitution. Hopefully you wrote somewhere that word, substitution, right? Make it easy to find. It's either section 6.3 or 6.4, all right? So it kind of limits your choices to look, all right? And then find the problems where you did some substitution, and my guess is it's probably very similar, if not exactly the same on the quiz, all right? But it's up to you to study, okay? That's why I just didn't want to do every single problem for you. Even the ones that we actually did, put some numbers in, they're not the same numbers as what's on the quiz. All right? Everybody good with that? Everybody ready to get 100 tomorrow? Good. That would be nice. That would be good. A free day.
Or if our average is above.
You can just get my appreciation. How's that? Yay. That's what you should live for, is just getting my appreciation. All right. So be ready for that tomorrow.